graphing quadratic functions, ax squared plus bx plus c equals y. So as we graph this, we've already graphed this using a table, and one of the problems with a table when we're doing a quadratic function is that we're not really sure where that quadratic function is on the graph. So if our quadratic function happens to have a vertex that's really like a very negative x value, a very positive y value, very high or low number, we may pick numbers for our table that don't really show us where the important vertex of our parabola is. So we're going to look at using the characteristics of a parabola to help us figure out where it is and help us graph it. So let's talk about some of the characteristics of a parabola, and we've talked about those in the last video. This is just part 2. So we're going to use the same equation, ax squared plus 3x squared plus 6x minus 4. And remember, this is what our equation looks like. So we want to realize that in this particular equation, a is 3 and b is 6 and c is negative 4. We're going to use that as we work through these characteristics. All right, so one point at a time. First, we're going to find the axis of symmetry of the parabola using this equation, x equals the opposite of b over 2a. So remember, the axis of the parabola, the axis of symmetry of the parabola is right through the middle, that vertical line that divides the left and the right side, so that we can see that they are symmetrical. So I'm going to take this x equals the opposite of b over 2a. I'm going to plug in my b, which was 6. I'm going to plug in my a, which was 3. I'm going to simplify this, and I get negative 1. So the equation x equals negative 1, which is a vertical line. That's my vertical line. That's the axis of symmetry. So that tells me where on the x-axis the middle of my parabola is. So I don't need to kind of guess where it is on the x-axis. Next, we're going to find the vertex of the parabola by substituting x into the equation and solving for y. So I'm going to take my original equation. I'm going to put x into that equation. Here comes my negative 1 right here. I'm going to solve that, and I get y equals negative 7. So if x is negative 1, y is negative 7. So my vertex is negative 1, negative 7. So I know that this parabola has a line of symmetry at negative 1. It's just to the left of the y-axis. It has a vertex that is below the y-axis. So I'm looking at the underneath, kind of that in my third quadrant there. Next, let's find the y-intercept. So the y-intercept of the parabola is going to be at the point 0, c. So remember, c is my last value here, my constant at the end, which kind of feels slope-intercept formish, having that plus, that c at the end there. That's going to be my y-intercept. So c is negative 4, so my y-intercept is 0, negative 4. So I'm already imagining this point here is in the third quadrant, and that my y-intercept is above that on the y-axis. Negative 7 is below negative 4 on the y-axis. So I'm already starting to get the picture that my parabola opens upward. The next thing we're going to do is we're going to determine if the vertex is a minimum or a maximum. And how we can do that is by looking at a. So my value of a, which in this case is 3, if a is positive, it's a minimum. If a is positive, then it is a minimum value. It's at the bottom. And if a is negative, then it is a maximum. It's at the top. And I also like to think about if we have positive, I'm going to write on this board while I'm doing this, that would be a smiley face. So that's what my parabola looks like, which means the vertex is at the bottom. It's a minimum. And if I am negative, I've got a frowny face, which means that my vertex is at the top, which means it's a maximum because it's at the top. So positive is at the bottom, negative, the vertex is at the top. And the last thing we're going to do is we're going to go back to making a table of values. However, now we know that the table of values will show us a symmetrical the symmetrical two sides of our parabola. So I'm going to use the vertex as the middle value in my table. So here's my vertex in the middle of my table. And then I'm going to pick x values that are kind of at equal intervals away from my vertex here. Because then what I can do is I can do half of this table, and the other half will be a mirror image of it. So if I figure out and I'll do the positive ones. If I figure out 0, I know that's negative 4, because we did that with our y-intercept. If I plug in a 1, I get a 5. If I plug in a 2, I get a 20. But I'm going to know that those mirror each other on the other side if they are the same distance away from my vertex. So I can really kind of make half of the table and then fill in the other half because they are mirror images of each other, as long as I know what the vertex is and I'm putting that in the middle. So from here we're going to graph it. This looks surprising like our last graph because it's the same equation, but we came up with our vertex down here at -1, -7. I've got my y-intercept here on the y-axis. This is a minimum because the parabola is opening upwards, and there's my parabola. Please remember that when we graph that, it's a rounded bottom. It's not a V as we go. And this opens up, and it gets really large really fast. So graphing our parabola from different characteristics of a quadratic function.